Hello students, welcome back to the fifth unit, that is analysis of univariate data. And here I am going to start the topic measures of dispersion or variation. Madam has already started analysis of univariate data. In that she will teach measures of central tendency and the partition values. Now I am going to deal with the measures of dispersion or variations. First we will see the definition of measures of dispersion or variation. Measures which measure the lack of uniformity are called measures of dispersion. Measures which measure the lack of uniformity are called measures of dispersion or measures of variation. Then it has some objectives of dispersion. First objective is to judge the reliability of an average. Whatever the measure we are going to find, it should be reliable. So to judge that the reliability of an average, we are going to study the dispersion. Then to compare two or more series with respect to its variability. The next objective is to serve as a basis for the control of variability or dispersion. Then the next is to enable the use of other statistical measures. So these are the some objectives of dispersion. Now we will see the essentials of a good measure of dispersion or requirements of good measure of dispersion. The first essential is it should be easy to understand and simple to calculate. Whatever the measure of dispersion or variation we are going to find, it should be easy to understand and simple to calculate. Then it should be based on all the values. Whatever the measure we are calculating, it should be based on all the observations, all the values. The next essential is it should be well defined by a mathematical formula. Whatever measure for dispersion we are going to find, it should be mathematically well defined. Then it should not be affected by abnormal extreme values. Here abnormal extreme values means as compared to the entire data, any value is too small or any value is too big, then such values are called as abnormal extreme values. So whatever the measure we are finding, that should not be affected too much by these abnormal extreme values. Then it should be capable for further mathematical treatment. Whatever the measure of dispersion we are going to calculate here, it should be capable for further mathematical treatment, or it should be useful for further statistical analysis. Then it should be possess sampling stability. For different samples, if we calculated any statistical dispersion, then it should be stable. It should not vary too much. It should be stable for all the samples. Then it should be easily calculated for an open-end distribution. We have seen that what is meant by open-end distribution. The class intervals like below 10, above 50, such class intervals and its distribution are called as open-end distribution. So it should be easily calculated for open-end distribution. Then we are going to study the absolute and relative measures of dispersion. There are two types of measures. One is absolute measures, another is relative measures. First we will see the absolute measures of dispersion or variation. Absolute measures of dispersion are expressed in the same statistical units in which original data are given, such as rupees, kilograms, etc. These measures may be used to compare variation in two or more distributions, provided the data are expressed in the same units. So whatever the data is expressed in which unit, the absolute measure is measured or expressed in the same unit. That is called as absolute measure. Then we have the relative measure. A relative measures of dispersion is one which is independent of units of measurement of variable and is suitable for comparative study of variation. Measure of dispersion and the unit of a data, they are independent. There is no unit for relative measures. Then we have types of absolute measures of dispersion. So there are 4 types of absolute measures. First one is range, second is quartile deviation, third is mean deviation, and fourth is standard deviation. Now with respect to these 4 absolute measures, we have the relative measures also. So there are 4 types of relative measures because we have 4 types of absolute measures. Now if we consider range, then its relative measure is coefficient of range. Similarly, absolute measure is quartile deviation, its relative measure is coefficient of quartile deviation. Like that, the absolute measure is mean deviation and its relative measure is coefficient of mean deviation. And the last is absolute measure is standard deviation and its relative measure is coefficient of standard deviation. So these are 4 absolute and 4 relative measures of dispersion or variation. Now first measure, absolute measure we will study here, that is range. The difference between the highest value and the least or lowest value in a given data are called range and it is denoted by R. The difference between highest value and the lowest value or the least value in the data are called range and it is denoted by capital R. Now we will see the computation of range. It is for ungrouped data. R is equal to H minus L here. Range is equal to H minus L, where H is the highest value and L is the least value or lowest value in the data. Then the relative measure of range is known as the coefficient of range and it is given by coefficient of range is equal to H minus L divided by H plus L. That is highest value minus lowest value divided by highest value plus lowest value or least value. Now we will see the merits of range. Since range is nothing but highest value minus lowest value in the data, so it is easy to understand and simple to calculate. Then second merit is it is mathematically well defined. We have the range formula is highest value H minus lowest value L, so it is mathematically well defined. Also it has some demerits. Since it is based on only the highest and lowest value, it is not based on the all the observations, so it is a demerit for the range. Then as we have seen that highest and lowest value are the extreme values, so range is highly affected by the extreme values. If any one value is too small or too big as compared to the other values in the data, then the range is highly affected by these extreme values. Also, for different samples you will get different value of range, so it has no sampling stability. So these are some merits and demerits of range. Now we will solve small examples on range. This type of examples you can expect in the exam for 2 marks each. Let's see the first question. Calculate range and coefficient of range for the following data, and here we have the data 139, 150, 151, 151, 157, 158, 160, 161, 162, 165, 167 and 175. Now here we will find the highest value and lowest value. If you observe the data, the highest value is 175 and the lowest or least value is 139. So highest value is 175, least value is 139. Therefore we have the formula to calculate range. R is equal to H minus L, that is 175 minus 139. Simplify this, you will get range is equal to 36. Then we have to find the coefficient of range, and we have the formula for coefficient of range, that is coefficient of range is equal to highest value minus lowest value divided by highest value plus least value, that is h minus l divided by h plus l. Now put the values. H is nothing but 175, l is 139 divided by 175 plus 139. Now 175 minus 139 is 36 and 175 plus 139 is 314. So 36 divided by 314, after simplification we will get 0.1146. So the coefficient of range is 0.1146. So these are the values for range and coefficient of range. Now let's see one more example on range. Find range and its relative measure from the following data. And here we have the data 40, 85, 100, 15, 5, 70 and 65. Now if you observe the data, then we will find that highest value in the data is 100, so HV is equal to 100, and least value is 5, so lowest value is equal to 5. Then we have the formula R is equal to H minus L, that is 100 minus 5, then you will get range is equal to 95, R is equal to 95. Then the relative measure of range is the coefficient of range. Relative measure also we have to calculate. So the coefficient of range is equal to H minus L divided by H plus L. Put the values of H and L, then we will get 100 minus 5 divided by 100 plus 5, which is equal to 100 minus 5 is 95 and 100 plus 5 is 105. And after simplification, 95 divided by 105, you will get 0.9048. So these are the examples on range and coefficient of range. This type of examples you can expect in the exam for 2 marks each in section B. Then next class we are going to study the coefficient of quartile deviation and quartile deviation. Thank you.